Hello everyone, and welcome to our second video over Systems of Equations Part 2, 3 variables. We're just going to jump right into this last example. We start by labeling our equations, 1, 2, and 3. If you notice, before I had this question on the previous page, I went and moved it down, gives me a little bit more space to work with. We are going to start by taking two of our equations and eliminating a variable. What's cool about this equation is if you'll notice, give me 1 second. If you'll notice, equations 1 and 2, both x and y have the same coefficient. What that means is what's going to happen is if we use elimination on these two equations, as long as we use it on either x or y, actually both of them are going to end up canceling out. And so we'll immediately get to solve for z when we use equations 1 or 2. We still have to solve for the others, but solving and being able to solve for that z will make this process be a little bit shorter than previous ones. So I'm going to go ahead and choose x. Obviously, like I just said, it's going to cancel out y too. But what do we need? We need the same coefficient. There's already the same coefficient of 1, and we just need 1 to be negative. So I start by just writing down my equation 1. I'm not going to change equation 1. But I do need to change equation 2 by making it negative. And when I multiply equation 2 by negative, that gives me negative x minus y minus 3z equals a negative 14. And then just like we do with regular two variable equations, to eliminate, we go ahead and add them together. So now the x's cancel out and the y's cancel out. 2z minus 3z is a negative z. And so we get that negative z equals 11 minus 14, which is a negative 3. Now you can divide by negative to solve for z, or you can just see, hey, what does z have to be to make this equal to this? Well, it has to be 3. So we get that z has to equal 3. Okay, now we can use this, and using any two of our other equations, we can plug in z, and what that will leave us with is a systems of equations with only two variables, and we know exactly how to solve these. So I'm going to use questions 2 and 3, and we know eventually we're going to need to use either elimination or substitution. So I'm going to go ahead and choose a variable. I'm going to choose x, which means we need to make equation 3 negative. We could also make equation 2 negative. I'm going to make equation 3 negative. So we're just going to rewrite equation 2. We're not going to change anything with it. It's x plus y plus, what do we know z is? We know it's 3, so 3 times 3 is 9 equals 14. And then on the other side of things, for question number 3, we're going to have negative x, because we're multiplying everything by a negative, minus 2y plus z now. And what is z? Z is 3 equals negative 5. And then just like before, we are going to add those together. Our x's cancel each other out. Y minus 2y is a negative y. 9 plus 3 is 12. And then 14 minus 5 is a 9. And then we can just go ahead and solve for y. It's an equation with one variable. We know how to solve those. We get y by itself. We start by subtracting 12. 12's cancel out, and we get negative y equals a negative 3. Again, just like z, what does y have to be for this side to equal that side? It has to be a 3. So y equals 3. Now, a good strategy whenever you find an answer is to ask yourself, is that what I was looking for? Now, what are we looking for? Well, what does a solution to a 3 by 3 system of equations look like? Well, it looks like a point, x, y, z. Now, we know z, we know y, but neither of those are a solution. A point is our solution. What do we need to make that point? We still need our x. And we can find x by just plugging our y and z into any of these equations, or we can go ahead and use what we created right here, plug y back in. There's a bunch of different options. I like to go ahead and just plug my parts into one of my equations. It keeps me personally from getting confused. And so if I plug it back into equation 1, we get x plus y, which is 3, plus 2z, which is 2 times 3, which is 6, and then equals 11. 6 plus 3 is the next operation we're going to do to start simplifying this. And that gives me 9. So our equation becomes x plus 9 equals 11. To solve for x, we subtract 9 from both sides. 9 minus 9 is 0. 11 minus 9 is 2. So we get that x equals 2. Now, we have all three parts, but we haven't written the solution yet because what does a solution look like? It looks like a point. You can likely expect that to be an extra credit question on your exam. What is the solution to a system of equations? It's a point. And this as a point is 2, 3, 3. And that is our solution. Alrighty, so that's the end of Systems of Equations Part 2, 3 variables. We're going to do a lot more practice problems in class, so I will see y'all then.